What's up, everybody? Today, I am going to show you the best way of learning domain-driven design, clean architecture, CQRS, and software design principles in practice. As you might know, we have a lot of interesting books out there which helps us to gain a lot of valuable information about domain-driven design, about clean architecture, about secrets and other stuff. But nowadays, most of the developers don't have enough time to read books, or maybe they don't want to spend time reading books. Of course, I don't admire this approach, but it is what it is. And in the era of AI, we want to learn everything really fast. That's why I think using tutorials and using the real world examples from GitHub or other sources will help you to reach your destination. And for that reason, I'm going to show you one of the best domain-driven design CQRS clean architecture repository, which was implemented by me, and I hope you will like this repository. I have provided almost all possible best ways of implementing domain-driven design and clean architecture. You can just check the README file here. This is a real world example. This is not just a demo example. Of course, in GitHub repository, you may find a lot of interesting repositories which demonstrates domain-driven design, clean architecture, security, and other stuff. But fortunately, most of them just a garbage for me because they don't demonstrate the real world examples. They are just pet projects, simple pet projects. Of course, we have a lot of interesting real world examples, but for me, the best way of implementing domain driven design, clean architecture should look like this. And that's why I implemented this repository. So here we have a lot of interesting features. As you might guess, we have basket management. It is not important if you are not implementing this bounded context. That's completely okay. You can just check my implementation way and adapt it to your bounded context. That's completely okay. The main point here is to see the approach, how I have implemented domain-driven design, clean architecture, CQRS, and other design principles and patterns. Okay, so as you might guess, we have coupon system, we have implemented clean architecture, we have domain-driven design. I tried to implement almost all possible patterns from domain-driven design, like ubiquitous language, bounded context, value objects, entities, aggregates, domain events, domain services, application services, repositories, factories, modules, and more. And we also have cross-cutting concerns like logging, validation, exception handling. And here I have provided event storming board for you. Before diving into details of the source code, please check the event storming board. It will help you to understand why we implemented such type of features, and event sourcing will help you to understand mainly the core ubiquitous language used in our application. And we have a clean architecture overview. Right now I have the black background, and that's why it is not visible, but I have provided a really good high level view of clean architecture here. And we have the clean architecture implementation using domain layer, application layer, infrastructure layer, and API layer. And also we have interaction flow here, and this interaction flow will help you to understand how internally application request flows. First, we have user sends request to the web API. We have the application layer, which handles the API query using CQRS, and it forwards, it acts like orchestrator between domain models. And we have domain models that we are retrieving, we are manipulating, and domain models rises error, and this error will be catched by event dispatcher. And for the event dispatching, we have events and event handlers. Our events will be catched by event handlers, and if you want to go outside of your bounded context, we have integration events that will help you to publish. For example, in our context, we have Kafka implementation. You can push your request to the outside using Apache Kafka. I've tried to implement almost all possible best practices related to domain-driven design. As you might guess, I've provided the short definition of the domain livings, like entities, value objects, aggregates, domain events, domain services, and with one or two examples. And following this example, you may find a lot of other examples in our application, of course. So you see, we have approximately 12 domain-driven design parents here, but that's not all. Of course, I have used other design parents, let's say from the Gov parents. For example, we have the Greg Young's CQRS here. We have result pattern from the functional programming. We have decorator, mediator, publisher, subscriber, strategy, template method, factory method, chain of responsibility, unit of work, and more. If you really want to see all these patterns in practice, in real world examples, this repository is one of the best to investigate and to learn all these concepts using only one project. And I have provided technology we have used it and the simple prerequisites how you can easily run this application. And we have project structure. So just go to the repository. The repository is called the real DDD CQRS clean architecture. This is Troll Suleiman in my GitHub repository, and I hope you will like it, and I hope you will start this repository after reviewing. So let's dive into details of this project using Visual Studio. In our application, as you might guess, we have two main folders. They are source folder and test folder. In our source folder, we have clean architecture and shared library functionality. And in tests folder, we have unit tests plus the test data. Of course, I have just implemented unit testing here, and I will add integration tests, of course. But for now, I approximately implemented all possible unit test scenarios for this project. Let's start from the source folder. You should first try to understand the domain layer here. In our domain-driven design applications, if you are implementing microservices using domain-driven design approach, as you know, we have special naming rule. In our case, we have work consulting, flame, basket context, domain. Work consulting is a component name, flame is application name, basket context is a bounded context name, and the domain is the layer name. So we have basket elements. These are modules. Okay, we have coupon and we have common. In our basket, you will find all the entities, aggregates, value objects, events, services related to basket, and same is applicable for the coupon also. After reviewing our event storming, you will understand why we have basket and coupon implementation. And here we have implemented approximately all possible domain-driven design, strategical and tactical parents. For example, our basket is aggregate root. Our coupon is aggregate root. Aggregate root is a type of entity which has possibilities related to events. You can add events, clear events, pop events, and more. Just go to definition. I have implemented approximately all the base classes using by myself. I haven't used any libraries here. So you see we have aggregate root. It inherited from entity and it has this sort of functionalities. The best way of exploring this repository is you don't need to implement everything from scratch. I will have series of tutorials which help you to understand this project in detail, but this is just overview video which help you to understand the high level implementation of domain driven design, clean architecture, CQRS, and the software development best practices. Okay, so just go to Consulting Flame common.domain, and here we have all sort of contracts, abstract classes for our application, all sort of our aggregates inherited from aggregate root. If you have entity, your entity should inherit from abstract entity class. If you have value object, your value object should inherit from abstract value object class. Also, I have mentioned that if you want to use records, there is no need to implement such type of class, because the records will handle all the equality component functionality. Okay, and we have the common functionalities related to our domain inside our Consulting Flame common.domain. As you might guess, I have errors here, I have related events, I have exception handling mechanism, I have validation extensions, I have common services like ID time provider service, and this is a domain service we implemented for shared usage. And after exploring our basket context domain, you will understand, of course, using event storming diagram, you will understand why we implemented our class in this way. Of course, in our domain layer, we are throwing exceptions. For example, I have extension methods here. I tried to implement approximately the best way of using domain-driven design as far as I know, but it is always open for maintaining, for extensibility. It is open for changing. In the future, I will add more features, and maybe I will change some part of this application. That's completely okay. So in our domain layer, I'm throwing exceptions, but catching these sort of mechanisms using result in a domain layer is also completely okay. I mean, you don't need to throw exceptions. You can just easily wrap them to result and send it to the application layer. This is also completely okay, but I have used the exception throwing mechanism here. Okay, and this is an extension method series for these entities, aggregates, and value object validation. For example, in our basket, we have, for example, ensure positive. Ensure positive is a checking mechanism, will help us to check if the given value is positive or not. So I have approximately all sort of extension methods for all sort of scenarios, but in the future I may add or remove some of them. That's also completely okay. So long story short, in our work consulting Flame common domain, we have domain layer, shared domain layer features. Okay, the features related to the business, to the core domain. And in our exact domain layer, we have exact implementation based on our bounded context. So you can just create NuGet package from this library. I will create a separate NuGet package that will help you to just easily install and use its features. But right now you can just by yourself create your own private NuGet repository and use it. And our basket context domain is using this Flame common domain. And the next layer in our application is going to be our application layer. The responsibility of our application layer is to handle commands and queries using CQRS. In our web API, we have request mechanism, and we are requesting some data, and we are forwarding it to our application layer using CQRS. And here, for example, we have create basket. So as you can see, I have feature-based mechanism. Like, it is not completely vertical slice architecture, but the structure looks like this. So we have create basket. In our create basket, we have create basket command handler. Okay, the command handling mechanism is really easy, and because we have common handler base, which we have wrapped all the repeated steps into one abstract class. And using template method parent, you can just inherit and rewrite the exact execute async. So every time when we are handling our request, we have a special core handling mechanism. We need to commit to our unit of work, to our database or other source, it doesn't matter, and we need to dispatch our domain events. Okay, this is the common scenario for our command handlers. That's why we have command handler base, and we have validator. You don't need to integrate. As you might guess, I don't have any validation rule here because I have cross-cutting concerns in our behaviors on the application. So you see, we have exception handling pipeline behavior, and this pipeline behavior will help you to handle the validation stuff. And we have logging and we have validation. It will handle our exception. Sorry, we have logging and we have validation here. Okay, so for every feature like create basket, clear basket, calculate total amount, you need to implement three classes. They are commands, command handlers, and related validators. And that's all. System will automatically catch your validator and handle the validation process. And your validation, of course, will throw exception, and our exception handling pipeline behavior from mediator will automatically catch it and wrap it to result parent. Let me show you how in general things look like. So in our common handler, so you see we have really simple application layer logic. Like in our basket repository, we are checking if customer exists. If not, we are returning a result. Of course, before it, we have validation. We are validating create basket command, but you don't need, as I mentioned, write it here, because this create basket command will be automatically triggered using our validation pipeline behavior, and all the validation will be done there. And the exact execute method will be triggered only if the create basket command is valid. So the system, if system creates create basket command, it will call our execute method. And we have a domain model orchestration, like aggregate orchestration in our application layer. So you see we have basket here, we have customer information, and we are creating our basket and we are adding it to our repository. In this case, I have implemented repository parent and unit of work pattern for you to work with your data storage, and we are returning the result, not throwing exceptions. Of course, domain layer throws exception, but as I mentioned, exception handling pipeline behavior will catch it and will provide the value for you as result. Okay. So in our application layer, we have implemented events. For example, we have dispatching mechanism, our domain models like aggregates. Let me show you. In our domain layer, we have basket, and when you interact with basket, you have events. We have event-based design, and when you change the state of your aggregate, it will raise some domain event, and using dispatching, we will push these events, and the appropriate listeners will listen and catch and will continue the flow of handling these domain events. So in our case, we have domain event dispatching. So you see, I have implemented it without mediator. This is a bit complex, but with mediator, it is really easy to publish our domain events. The domain events will help us to notify the changes about our aggregate inside our bounded context. But if you want to go outside of our bounded context, you should map it to integrated event and raise integrated event. Okay, I will show this example also. So in Our application layer is mostly responsible for our use cases. You have orchestration mechanism because in one domain model you are storing a part of business related to use case. In another domain model you are storing another part of business. So we need to orchestrate them to get one use case. That's why we are using application layer. And also it is responsible for publishing our domain events. And of course, as you might see, we have integration event here. So this integration event will be handled in our infrastructure layer because we are going outside of our bounded context. For example, we need to publish this event to message queue, and we will implement the exact implementation of message queue in our infrastructure layer. And we have repository interfaces. Why I haven't put these interfaces to domain layer? Because I don't think that it is a best way of implementing repository interfaces in our case. Why? Because in my domain layer, I'm not using these interfaces. You should this is a bit design decision. If you have the exact implementation for your interfaces, if you are actually using these interfaces in domain layer, it is you should put them to domain layer. If you are not using them in your domain layer, it would be better to move them to the upper layer like application layer. Okay, in my case I put them to our application layer. And we have extensions. Using these extensions, I am providing that, okay, if you want to use the functionality of application layer, just add application layer. So let's go for it and see. So you see in our program CS we have add application layer, and that's all. We are integrating our application layer. And of course, we have infrastructure layer. The responsibility of infrastructure is to work with outside elements. If you have mail sending, if you have working with GraphQL, Apache Kafka, external services, databases, you should put all these mechanisms implementation inside your infrastructure. For example, I have put my interfaces to the application layer, but this interfaces implementation will be stored in our infrastructure layer. So you see, I have persistence, I have all sort of entity framework configurations, I have all sort of entities here, profiles for mapping. As you can see, I have the exact unit of work implementation, I have DB context here, I have all sort of repository implementations. So you see, we have repositories folder and I have basket repository. So you see, I've put some logic to the database stuff because it is responsibility of my database. Anyway, so you see in our infrastructure, we are handling all the exact implementations related to the outside world. Okay. And the higher one is our API layer. So we have simple basket controller here. The responsibility of basket controller is actually getting the request data from the user and forward it to the lower layers, let's say. In my case, for example, we have create basket. The creation is a command, not query. That's why we have create basket command. And using senders send, we are forwarding it to the application layer actually. Okay. And the combination of infrastructure application will handle all this stuff for us. And of course, I have implemented base controller that will help us to easily work with controllers. I don't have too much logic because you should not put the logic to your API layer if they are not related to the API layer. For example, if I need to wrap some data from the lower layer to the bad request, I don't know, to the 404, 400, 500, of course, I should interact with API layer. Otherwise, you should not add any logic to this API layer. So just check this controller. I will add more features. Of course, we haven't implemented all possible endpoints for basket for coupon, but I will add them one by one. So this application will help you to understand domain-driven design, clean architecture, and of course, the best way of implementing software. Okay, we have a lot of design patterns, we have a clean architecture, domain-driven design, almost all possible domain-driven design patterns in this project. And of course, we have tests. How it is possible to write application without tests. So in my case, so you see, I have almost implemented all possible best ways of using unit tests in this application. So you will find exactly the best way of using unit tests. I will create a series of tutorials to explain almost all possible parts of this application. I will start from the unit tests, and using these implementation, you can easily understand and adapt it to your current projects. So that's what I have implemented, and I hope you will love this repository. Just go to the Tural Suleimani GitHub. In my Git, you will find the real domain-driven design, CQRS, and clean architecture. And this application will help you to learn real-world domain-driven design, clean architecture, and the modern software design principles and patterns in practice. So that's all from my side. Thank you very much, and see you in the next tutorials. Bye.